Hey everyone, it's Alice here at Top Mark Science, and welcome to my video today on atoms of elements. Today, we'll be exploring atomic masses and numbers on atomic symbols, how to calculate subatomic particles in each atom, and patterns of atomic structure on the periodic table. Let's get going. If you are watching this video, you must have learnt a bit about the periodic table before. If not, I cover this in another video, so feel free to catch up. In this video, we'll focus on specific atoms on the periodic table and see how we can use the periodic table to learn more about them. As we've seen in a previous video, stuff is made of stuff. This stuff is smaller stuff, called atoms, which are organised on the periodic table according to their properties. They're displayed as symbols, like this one here, helium. Now these symbols will often show numbers above them and below them. The smaller number is the atomic number. This shows us the number of protons an atom has in its nucleus, which is the same as the number of electrons that orbit the nucleus. The larger number is the atomic mass, aka how heavy an atom is. It's the number of protons plus the number of neutrons within the nucleus. For example, helium has an atomic mass of 4. But look at this diagram. It only has 2 protons. How many neutrons should it have? Well, it should have 4 particles in that nucleus. So I need to add 2 neutrons. But I'll let you in on a secret. There is a shortcut. To work out the number of neutrons in a nucleus, using the symbols is simply just the big number, take away the small number. Voila! See? Here is our first learning checkpoint. Pause the video here and have a go at determining questions 1 to 3. If you finish these, try the challenge below. Time to see how we did. Get your marking pens at the ready. This symbol is for oxygen. Its atomic number is 8 and atomic mass is 16. If you tried the challenge, good job. Oxygen has 8 protons, which means it has 8 electrons. And the number of neutrons is calculated by doing the big number take away the small number. In this case, 16 take away 8. So it has 8 neutrons. Excellent work, guys. Let's get some more practice with some others. Pause the video here and repeat what you have just done for these other atoms. If you finish, try the challenge. Time to mark our work. Marking pens at the ready. Pause the video if you need more time to allow to mark your answers. Magnesium has 12 protons, 12 electrons, and 24 take away 12 neutrons, which gives us 12. Here are the challenge answers. If you found these hard, you can watch my video on the periodic table to help. Calcium is 20, 20, and 20. Challenge answers here. Sulfur is all 16. Challenge answers here. Lithium is a bit quirky. Using the information, we can say it has 3 protons and 3 electrons, but 4 neutrons. Challenge answers for lithium below. Nitrogen is all 7, along with the challenge answers. Chlorine is 17, 17, and 18, plus challenge answers. And here are neon's answers. Pb is lead. It's a heavier atom, as you can see, with many more protons, electrons, and neutrons. And here's the answers for krypton. And last but not least, the smallest atom we know, but is a bit strange, with 0 neutrons, hydrogen. Well done, guys. Excellent stuff. Now we're going to look at the arrangement of electrons using the periodic table. The group number tells us how many electrons are in the valence shell of an atom. valence just means outer shell. For example, group 1 atoms have 1 electron in their valence shell. Group 2 have 2 electrons in their outer shell. You can probably spot a pattern here. Period numbers tell us how many shells are around a nucleus. Period 1 atoms all have 1 shell. Period 2 have 2 shells. Again, you can probably spot another pattern here. So I'll work you through an example of how to use the periodic table to draw atoms. Take hydrogen. It's in period 1. I draw 1 shell. It's in group 1. I draw 1 electron on its valence shell. Lithium is in period 2. So now I need 2 shells, and they should be filled using the 288 rule. More on this in my atomic structure video. Lithium is in group 1, so I add 1 electron to its valence shell. Your turn. Pause the video here and use the periodic table to draw the atoms highlighted on the screen. I have left my example on for you, or you can re-watch the previous examples again. If you finish, try the challenge. Time to see how we all got on. Starting with sodium. It's in period 3, so I need 3 shells. It's in group 1, so I add 1 electron to the valence shell. Following the 288 rule to fill up the other shells, I have my completed atom here. Now potassium. It's in period 4, so it has 4 shells. It's in group 1. It has 1 electron in the valence shell. Now I fill in the other shells using the 288 rule. On to the next set. We have beryllium, magnesium, and calcium as shown, all in group 2, so should all have 2 electrons in their valence shell. Pause if you need to look for longer so you can make your checks. Group 6 are now on the screen, oxygen and sulfur. They have 6 electrons in their valence shell. Versus group 7, which have 7, fluorine and chlorine. Now time for group 0. Helium is a small atom in period 1, so it only has 1 shell, but it's in group 0. This means that the shells are full, so in theory, they should add another shell, which would be empty. But there's no need to do this. It would just add confusion. So just fill up the inner shell, which has a capacity for 2 electrons. Neon is in period 2, with 2 shells, both full in a 2-8 arrangement. And argon in period 3, with 3 full shells of 2-8-8. Phew, well done. If you tried the challenge, having drawn all of these, you might have spotted a pattern. As you go across and down the periodic table, atoms get larger and get more electrons, and therefore more shells. Good job if you got any of these correct. Now a challenge game I reckon we can all try and play. An atom hunt. Use the electron arrangements listed to identify the atom in the periodic table. Pause the video and have a go. Replay when you are ready. Time to spot the atoms. Well done if you had a go. An electron arrangement of 2, 1. 2 numbers means it has 2 shells, which means it's in period 2. The final number indicates the number of electrons in the valence shell, in this case 1, which means it's in group 1. Lining them up brings us to lithium. Feel free to pause the video here if you would like another go now that you have seen an example. Repeat the process for the next one of 2, 2. 2 numbers is 2 shells, which is period 2. The last number is 2, which means group 2. This brings me to beryllium. And repeat for sodium and calcium and the others listed here. If you managed any of these, fantastic work! Time to round off with our quiz to see what we have learnt. Question 1. The atomic number is the number of protons. Question number 2. How do we calculate the number of neutrons using the periodic table symbols? Atomic mass, take away atomic number. If you put the big number take away the small number, I will accept this. Question number 3. The group number tells us what about an electron arrangement of an atom? Yes, the number of electrons in the outer or valence shell. Question 4. The number of shells we draw is determined by what on the periodic table? And final question. What can we say about an atom with an electron arrangement of 2, 8, 5? It has 3 numbers, which means 3 shells, and 5 electrons on the outer shell. A lot has been covered today, but take the time now to review these objectives and rag your process. As always, be honest with yourself. It doesn't matter what colour you are, it's nice to have things to work on. Thank you so much for watching this video, guys. If you liked it and would like to see more videos from Top Mark Science, you can like this video and subscribe to this channel. I'll see you next time.